if it's undefined, it cannot be. This function is always defined.
So x would equal 0.
Exactly. Awesome. Good. I need to study the sign left and right. Look at this expression, and I'm hoping you're going to say, oh, you cannot study the sign of this. There is nothing to study. You cannot study the sign of 16. There is nothing to study. You can only study the sign of x. So let's study the sign of x. When you plug in a number to the left of 0 in x, what is the sign?
Positive.
Careful. So in x, I plug in a number to the left of 0. Like negative 10. So what will be the sign?
Oh, negative.
Yes. Now let's plug in a number to the right of 0. What will be the sign?
Positive.
Exactly. Moment of truth. Moment of truth. If these two rows do not communicate well, then I'll say, oops. Moment of truth. Okay. From 1 to 0, what does the function do?
Decrease.
Yes. Is that supported by the sign of the derivative?
Yes.
Yes. From 0 to negative 1, what does the function do?
Decrease.
Yes. Is that supported? Yes. From negative 1 to 0, and then from 0 to 1, what does the function do?
Increase.
Is that supported? Yes.
Yes.
What type of point is 0, comma, negative 1?
It's a minimum.
Yes. Awesome. Finally, we can study the second derivative now. I'm not going to involve 16. It's a factor outside. If I had plus 1 or 16 plus 1, yes, it would have been a different story. So let's find the second derivative. 16 waits outside patiently. The top function prime, 1. X squared plus 4 squared minus the top times. Can anyone differentiate for us x squared plus 4, everything squared, and I'll put it here. And of course, the denominator is this squared, which is x squared plus 4 squared. Can anyone differentiate this for us?
We'd have to bring the 2 down.
Awesome. Times x squared plus 4 to 2 minus 1. Yes.
Mm-hmm.
Times the inner.
2x.
Yeah, exactly. Awesome. Please do not distribute. Please do not distribute. So we have 16 waiting, and I have an x squared plus 4, which is a common factor. I said squared, but I did not. Yes, I said squared, but I didn't square it. Sorry about that. Okay, now, one of these is out, so one is still left inside. This is out. So I have 2x times 2x, which is 4x squared with minus in front. I'm so happy to get rid of factors whenever I can. So now finally, 16. Negative 4x squared plus x squared is negative 3x squared and plus 4. And this is x squared plus 4 to the third. Yes, I hope you are allergic to negative leading coefficients as I am. That's what happens when I talk too much. I just said that. I just took it out. Sorry about that. Okay. So I pulled out a negative 1. So that's why we have positive 3x squared and minus 4. So now, the second derivative can be 0 or undefined. No. So it can be 0. Which quantity, which piece of this can be 0 when x is 0? When the function is 0.
The numerator?
Yes. So 3x squared minus 4 equals 0, or x squared equals 4/3, and we take the square root, so x equals plus or minus the square root of 4/3. I have no idea what that is. So the square root of 4 divided by 3. 1.2, roughly. So x equals plus or minus 1.2. Back to the table immediately. Yes, of course, I have to squeeze them in there, but it's okay. Finally, we have to study the sign of the second derivative. I refuse to study the sign of this because it's always positive. I refuse to study the sign of 16. So the only sign that I have to study is of 3x squared minus 4 with minus in front. So let's start by plugging in 0. Can anyone plug in 0 in 3x squared minus 4 with a minus in front and give us the sign? Just the sign. No number is required.
Negative.
Yes, of course. Positive, right? So when I put in 0 here, I have -4, and -4 times -1. So this is positive. So here it holds water. Now let's plug in -10 or 10. So with -10 will be 100. So 300 minus 4, this will be positive with minus in front. Same thing here. If I put 10, this will be positive with minus in front. Now, I have to find this point. When x is -1.2, I have to find the y value. When x is 1.2, I have to find the y value. The function is even, because if you replace x by -x, it will be symmetric with respect to the y-axis. I'll refresh your memory on the types of symmetry in a minute. So let me just plug this in into x squared minus 4. I only need to plug in 1. So the numerator, 1.2 squared minus 4, and divide by 1.2 squared plus 4. So both numbers, yeah, they couldn't be more difficult to plot. -0.5. Final question, what type of point is -1.2 comma -0.5? I have to write it here. What type of point is 1.2 comma -0.5? And I have to write it here. And why?
Their inflection points. 'Cause that's where it changed
Absolutely.
from
Yes.
concave down
Exactly,
concave up,
exactly. They come from the second derivative when the second derivative is 0 in this case, and it changes sign. Excellent. At this point, I'm ready to graph. Everything is gibberish. I couldn't care less about anything. Doesn't mean anything. That was already taken into account. That's all I need. When we graph functions with asymptotes, I have to graph the asymptotes first. Mandatory. This function has some points, -2, 0, 2, 0. It has 0, -1. So -2, 0, 0, -1, 2, 0. And it also has these points of inflection at -1.2, -0.5, 1.2, negative 0.5. I have to draw the horizontal asymptote, which is y equals 1. It's not part of the graph. It cannot be graphed as a solid line. Ready? From approaching 1, opening down, decreasing to this point of intersection. Okay, fine. Continue to decrease to the inflection point, negative 2, opening down, decreasing and opening down, to negative 1.2, negative 0.5. Where it changes concavity, now it starts opening up and it gets to the relative minimum, which in this case is also the absolute. It continues to increase now to 1.2 comma negative 0.5, where it changes, still opening up, where it changes concavity, opening down, crossing the x-axis at 2, 0, and approaching 1 towards infinity. So changes concavity, opening down, getting closer and closer to the horizontal asymptote to 1. So this is f of x equals x squared minus 4 over x squared plus 4. A lot of work. I will not put a long problem like this one. It took me to explain, I don't know, 10 minutes on a test. You're going to have simpler problems, but you still have to be able to show that you can create this table, and based on the table, you graph. You can say, show me this graph, fine. The graphing calculator will not give us the point of inflection. It's not as smart as you are. So if you want to put in the graphing calculator function like this, you could. So don't forget parentheses, x squared minus 4, close, divided by x squared plus 4. Do not forget to put the horizontal asymptote. The calculator will not put it in. So that was y equals 1. I will choose the standard viewing window. It's not a good viewing window, but good enough. And as I mentioned, the calculator will not tell us where the switch change, the concavity changes from opening downward to upward. We do know it's at negative 1.2 comma negative 0.5 approximately. I've rounded them. So you see the horizontal asymptote, and you see the graph. The graph can be folded with respect to the y-axis because this is an even function. So next time, I will not